Hello everyone and welcome to the second installment in my walkthrough through Natas, which is a server-side web security wargame presented by OverTheWire. In the last video we went through level 0 and a bit of an introduction in terms of what to expect in this CTF wargame challenge. And we solved level 0, as I said. And in this video we're going to go over level 1. And if you remember from last time, we created a simple shell script which is going to allow us to connect, authenticate to the basic HTTP authentication provided for each level here. And essentially what our script does is make a simple curl request using that authentication, and we can obtain the source code of the web page or the HTML source code within our terminal window. But for now, I'm just going to open the URL here and see what we get. So I also forgot to mention, in the last video, we didn't actually save the password in our directory here. So if I cd to Natas 0 here, if I do an ls, you can see I actually put in that, I echoed out that password. I'll show you how I did that. So I'm just going to remove that real quick and basically just echo out that password we retrieved in the last level, make sure there's no space there, and send it to the file, Natas 0, we'll just call it. And if we cat that out, you can see we have the password there just in case we need it, which we will, because we're going to go over what this page looks like in the browser. So username in this case is going to be Natas1, because we're on the first level now. And we're going to paste in that password. And assuming everything works, it looks a lot like the first level, if you remember. You can find the password for the next level on this page, but in this case, right-clicking has been blocked. What did they mean by that? So if you remember last time, I talked about how you could actually view the source code of a web page by right-clicking somewhere on the page and clicking View Page Source. So if we try that now, you can see right-clicking has been blocked. We're getting a JavaScript alert message here saying that right-clicking has been blocked. So that sort of cancels out that attack vector we have to view the web page source. But fortunately, if you remember from the last video, I mentioned there are a couple different ways we can actually view the page source. And the other way I went over was just hitting Control-U on your keyboard. And clearly that's still going to work here. The JavaScript seems to only be blocking the right-click feature, so we're not actually able to open that little window to click on View Page Source. Again, like I said, we can just Control-U, and we have the source code of the web page. And you can see here, just like in the last episode, in an HTML comment, we have the password. So again, very simple level. We just solved it. The solution there was to basically evade that disabled right-clicking. And if we actually look at how that works, you can see here in line 11, we have this body tag, and we have the attribute onContextMenu equals, and essentially the value of this attribute is a inline JavaScript, and it's calling an alert saying right-clicking has been blocked. And that's what we're seeing when we go to right-click here on the body of this web page. You can see we have right-clicking has been blocked. And essentially, if you're asking how that's working, well, we can look up this HTML property, or this attribute, this onContextMenu. You can see here, if we open just the W3 Schools page here, this is going to tell us that the onContextMenu event occurs when the user right-clicks an HTML element to open the context menu. So again, that's what is occurring when we attempt to open the context menu being this, when you right-click here, you can see we have the context menu, and this is where we can click View Page Source. So this is all contained in the context menu event, which is a JavaScript event, or an event that JavaScript can listen for. And essentially what we have here is an event listener waiting for that on context menu event. And when it detects it, it's going to display a JavaScript alert, which essentially is twofold. It gives us this warning message here that they've provided, as well as preventing us from actually clicking on or opening the context menu. So I'm curious, if we just click Don't Allow the website to prompt you again, is this just going to avoid? No, it's not. So we still can't click on it. We're just not going to get that alert anymore because the event is being controlled by this listener. But anyways, that was a bit of a tangent, but I did want to show why, why that is happening. And again, if we want to solve this now through our script that we created, we spent all that time creating a script, we're definitely going to use it. So what I'm going to do is just back out one, and I'm going to call Natas. And do we still have the original password saved? Let me just make sure I have that copied. So I'm going to cut that out again, Natas 0, and I'm just going to make sure to copy that. And now I'm going to run our script, natas.sh. I'm going to provide the username, which is Natas1, and the password, which again, we retrieved from the last level. Whoops. Click run there, and you can see the same thing. We have essentially returned the source code to our terminal. I'm just going to full screen this, and you can see we have the password here. And if you remember from last time, what we did was actually grep this out. we just search for password, and that's going to return those 2 lines here. You can see in red where it indicates password, and you can see we've essentially filtered down that output to something more manageable. And something I didn't show in the last video, which I want to show now, is a way we can actually filter this out even more and actually save just the password to a file. Sometimes this is called like a get flag script. Essentially, when you're doing a CTF and you just want essentially like a one-liner that is going to get you the password or the flag and save it to a file. For this level, we can actually just use basically what we have already, just with a couple extra commands, which I'll go over. So the first thing I want to show is how can we actually filter down this password? You know, is there a specific string or specific pattern that we see with these passwords that we can actually maybe filter by or use some regex to filter on? And the first thing I thought of was actually the word count, because you can see, you know, this seems to be a random set of characters. The next password seems to be a random set of characters, but they do kind of look similar in length. And a quick way we can verify that is if I still have the first password saved there, so in my clipboard. So I'm going to echo, and then I'm going to, in quotes, paste that password, and then I'm going to pipe that out to WC, which is the word count command. And we're actually looking for the character count here, so I'm just going to do a tax C for the characters. And if we run that, we're going to get 33. Now, this isn't actually correct. So when we're actually running the echo command here, it's adding a new line character, which we can't see, and that's actually inflating this number by 1. Oh, and we're back. Okay. Apologies there. I don't know where we left off, but I realized I got a couple minutes in and realized the site went down. The Natas 1 level page went down. So I forget where we were. Let me try to walk back a bit. Talking about word count here, and if I echo this out with the tac n option and then put this in quotes, whoops. So what that's going to do is essentially get rid of that trailing new line character. So we're going to get a more accurate readout. And then we're going to do word count, obviously, with the tac C option. And as expected, we're going to get 32 instead of the previous 33 we were getting with that new line character. So the second thing I wanted to do now is if I rerun natas.sh, and if we put in natas1, for example, and the password that we were given. Okay, now we're back. So I'm going to copy the new password that we got here. Just for this get flag script. And I'm going to do a word count on this as well. So if I echo this out, replace this with this password, hopefully we get the same result. Okay, so that's 32. So at this point with our 2 examples, it might be fair enough to say that the passwords are going to be 32 characters in length, which is useful because we can actually use that value to extract the password just as a file, just through some new clever commands that we're going to learn here. So what I'm going to do, just clear this a bit, clean everything up. So I'm going to run this again. And what we were previously doing is just grepping password. And again, that's going to return those 2 lines here. But now that we have some extra knowledge that we know that this value is going to be 32 characters in length, we can actually use that to our advantage. And the first extra command we're going to pipe this to is called the tr command. So all this command does is essentially just delete or substitute characters from a given output or input or string that we give it. So we're first filtering for password. We technically don't have to, but just to clean things up, we're going to filter it as password. And then we're going to use this new tr command, and we're going to give it essentially first. Let me run this again and explain. So you see this output here. We have 2 lines. And each word is separated by a space, obviously. So we're actually what we're going to do is sort of delimit this by this space. And we're going to put each of these words on a separate line. And that's going to come in handy in a second when we use our second command, which is going to be the awk command. So again, I'm going to run tr, and the character that I'm searching for is a space. So in single quotes, I'm just going to put 1 space. And then the second argument we're going to provide is what we want to translate that to, or what we want to substitute the space for. And that's going to be a new line. So that's just the backslash there with the n. So now if we run this, you can see we're getting the same output here, but everything is being sort of delimited to a new line with that new line character. So every spot there was a space, it's now being translated to a new line. And ideally, or in theory, this line here is going to be a 32 character line. So what we can do now is run that same command. We're going to pipe it out one more time to the awk command. And I would highly suggest you look into this command. The amount of use cases for it is almost endless, but essentially it's described as a pattern scanning and processing language. It's its own sort of language that it has so many use cases. It's just extremely versatile. But we're going to use it just for a simple example here, and we're just going to search based off of the length, as I said earlier. So we're going to wrap this in single quotes, and we're just going to type, again, it has its own sort of language that it runs off of. So we're going to do length, and that's 2 equal signs there. 32, because that's the amount of characters we're going to be extracting. And then in curly brackets here, we're going to just write print. And we're going to hit enter here. And there we go. We just have our password exported or extracted out from that, originally from that entire curl command, then into the grep for the passwords. We have 2 lines, and then we split everything into a single line. So we have a bunch of different separate lines here. And then we use awk again to sort of sort by that or extract based off of the 32 character limit. And we now have the password. So what we can do now is, do I have a directory already made? No. So I'm going to make a directory for this Natas 01 challenge. And then what I'm going to do is run that long command again, that one-liner. I'm going to redirect the output of this command to a file located under that directory. And we'll just call it Natas 01. And now if we cut that out, you can see we just have the password there. And we can make sure that works by running our natas.sh script again. And the next level is going to be Natas 2. And if we provide that password, there we go. We can see we're in. We didn't get a 401 unauthorized or anything like that. So we can see that that worked correctly. So again, that's about it for this level 2. Pretty much the same as level 1, assuming we use some of the techniques that we discussed in the previous video. And hopefully you learned a little bit about get flag scripts and some different commands that we can use to extract data when we need it. So hopefully that was helpful. Like I said, I'm going to keep going through these levels in as much detail as I can. Again, we're starting out pretty easy here. This was pretty much the same as the first level, but it does ramp up pretty soon. And yeah, thanks for watching. So I will see you next time.